Okay, we talked about the slicing and indexing at the last lesson, and we will continue about the Numpy array. We're going to talk about changing the shapes, and sometimes you put the arrays together, and or split the array. And another one advantage of Numpy array is you can do a lot of calculations. So we are going to talk details about that. First is changing the shape of the Numpy array. So these are some of the functions to change the shape. The first one is a flattening array, which means that if it's a 2D array, you change it to a 1D array. That's called flattening the array. Okay, you can just try this code later. Transpose. If you have done Excel, you may be familiar with the transpose. Transpose is if it's 2 rows, 3 column array, it will be changed to a 3 column. 2 rows, 3 column array changed to 3 rows and 2 columns array. That makes sense. So if I have some data. If I have an array like this, 5, if you transpose, it will be how it will be. It will be 2, 4, 6, and 3, 5, 7. I used to use it a lot when I use Excel, when I use Excel or teach Excel. But after using Python, I didn't use it that much because it's more structured. You don't have to change the structure much. So for example, here, if I transpose this with this tool, okay, it may not have the tool. I don't have it here, probably. Yeah, I know it. The Microsoft Excel has it, but probably Google Sheet doesn't have it. So this is called a transpose, and then you can do the experiment on your computer later. And then the next is resize. Yeah. With resize, you can change it into any shape you want as long as the number of elements align with each other. For example, here, if I have 24 elements, either 1D array with 24 elements, or the B could be a 3D array with 24 elements, like 2 tables, maybe initially it had 2 tables, 3 rows, and 4 columns. So 2 times 3 times 4 is 24 elements. And this one, it will change the array into what shape? This one change it into a 2D shape with 2 rows and 12 columns. Or what other shapes you can change it to with this array? With this array, what other shapes you can do? Just name a few.
24.
Yeah.
What about just 1 by 24?
Yes, you can change it to 1 by 24 or 24 by 1, or you can change it to 3 times 8 or 8 times 3, as long as the number of elements align with each other. And here you will have to be careful. The resize method and the reshape method is a little bit different. They both change the shape. However, one changes the original array B, one doesn't. Let's try this. So if I use this resize function, let's say, yeah, let's print out a B here first, okay? Oh. Okay, see here, the resize function, it changes the function. The B was changed. It was this shape, and now it's changed to 3 times 8. However, if I use the reshape function, let's see what happens. If I use the reshape function, it didn't change the original array. So, but usually, always when you use the function, you assign to a new array. That makes sure, hey, this you get the new array. Okay. So for example, here, it's better to always to reassign this to another array. So you make sure this is changed, whatever function you're using. Okay, so yeah, I forgot to enlarge it. Forgot to enlarge it. How do you enlarge it? Okay, so this is changing the shapes of the array. The next one is what we often need to do is combine 2 arrays. So you may need to stack them horizontally, or you have to stack vertically. I sometimes got confused about horizontal or vertical. That's why there was once I was confused and had to take a few hours to figure out about. So here, for example, I have an array. So let's still use this B, okay? I'll use this C. Let's do a 2D array first. Let's just use a 2D array. Let's just use this 2D array C. C, right now the shape is 3 times 8. So if I want to stack another array horizontally beside it, what should it be? What should the shape be? If you want to stack an array beside it.
Would it have to be the same size, 3 by 8?
3 by 8 works, but it doesn't have to be 3 by 8. However, it has to be yes. Okay. If you want to stack that horizontally, the row number, as you can imagine, hey, if you 3 by 8 and the other area is the 4 by 6 or 4 by 8, if you're not stack right horizontally, it doesn't align with each other horizontally. So same if you want to stack another array vertically, then the column number should be the same. Here it's 3 by 8. You can have another column 4 by 8. Then it will stack vertically. Here there are 2 functions you can use for stacking. One is Numpy horizontal stack or Numpy vertical stacking to stack them together. And another function is Numpy concatenate. Concatenate can do either horizontal stacking or vertical stacking. So what you have to do is to tell it which axis you want to stack. So this one, it's only for horizontal stack. You don't have to do. You don't have to tell it the axis. However, this one you have to tell it axis. It takes two arguments. One is the number of arrays, which arrays you want to stack. This is the first. This is too small. A little bit better. So it takes two elements. This one is which elements, which arrays you want to stack, you want to concatenate. You want to concatenate AB or you want to concatenate ABC, as many as the array you want. And this one tells it the axis you want to get. Here, axis equals 1. That means that you want to stack them. Axis 1 is the column. I believe it stacks the arrays vertically. We can try it. I may be wrong, but either one means stack horizontally or vertically. And in some package, here Numpy is a concatenator. In some package, or maybe like later if you learn Torch, this method is called a concat. That also means a concatenator. See, let's do an experiment here also. So here is the C, array C we got. And for example, we got an array D. And they'll do 16. Got another array D, two rows, 8 columns. What can I do? Which stacking I can do? If it's 2 rows and if it's 2 rows and 8 columns, what I can do is do the horizontal or vertical. Which one I can do? Up, down, or side by side? No, C is 3 times 8. 3 by 8. D is 2 by 8. So has to be up and down actually. Yeah. So E would be numpy dot v stack C and D. Okay, so the problem here is that I often forgot that this one, you need another parenthesis. Okay, this only takes 1 element actually. So yeah. So what you have to do here is add appearances. This gives it the arrays you want to stack. So this is the new array. See, it goes from 24 and then added the D shape D here. Alternatively, we said we could do the concatenate. So if you do concatenate, you have to tell it the axis. I believe it's axis 1 because you are stacking up and down by the columns. But maybe I'm wrong, see? So actually has to be. So axis 0 means you are doing vertical stacking. So axis 1 means you are doing horizontal stacking. I was wrong actually. So just try some experiment to get familiar with this. Okay. As you see, we learned the concepts of axis at the last lesson, and we'll continue using it when you do these functions. So this is stacking, and another thing opposite to stacking is that you want to split the array. For example, here D is 2 by, let's just use D, okay? D is 3 by 8. I can do it horizontal split, and then it has to be some numbers can be divided by 8. Can be it has to be the either 2 or 4, but actually even if it's not 2, 4, or you want to has 3 columns and you want to split into like a three arrays of your work. I forgot if it will work or not actually. I believe it will work. I forgot which way it will work. Let's just try the experiment to see. Okay. Let's see. Let's see what it will return us. So C. I remember this correct. C, and let's try first. Let's try split into 2. Okay, so I didn't say H split. C is this one, right? C is this one, 3 by 8. See, if I do 2, it will horizontal split is split into by this line. Cut it, cannot show it, but it cut a line in the middle like this, right? However, let's try if it can split it into 3 pieces. I wouldn't expect it. I wouldn't expect it to split it, either return an arrow or it split into arrays that not evenly. So here, this function, it cannot work if you give it a number that cannot be divided under 8. So for H split, if you give it 3, it will not work. Maybe this will work. I remember one of the function works. So let's try Numpy split and see if it will work. So for example here, and I tell it, if you use this split number instead of H split or V split, you have to specify the axis. Axis equals 0. Okay. That means a horizontal split. Okay, actually this means a vertical split. So I try axis equals 1. And so you see it's the same, it returns an error because it cannot be split into evenly. I didn't remember there are some functions, even if it's 3, it can be separated into some areas. Probably I was wrong. And sometimes the functions they update all the time. Let's see. Okay. So this concatenate axis equals 0. That means you stack up and down. You add the arrows. That's correct. So, and if it's axis equals 1, that means you're splitting by columns. Okay, that's good. Oh, have any question here so far? You're good here? Okay. Next thing I want to briefly mention is that sometimes you want to remove some items or some rows and numbers, and then you can use the function numpy.delete. Okay. The structure of this function is that you tell it which area you want, and you tell it the position you want to remove, and the axis. So if it's axis equals 0, you delete 1 row. And if its axis equals 1, then you delete 1 column. However, for 2D array, you cannot delete 1 cell because the shape will not match. Usually you either delete a single row or you delete a whole column. So here, for example, what this does, what this delete. There's an original array 2D, and then you delete 1, and this 1 is the row number. Axis equals 0 means that delete 1 row. So this actually delete the which row? So this is the position number 1. 1 means the
second row?
That's right, the second row. Everything starts with 0. So this code it delete the second row number. If you change this to axis equals 1, then it delete the second column. Okay, then how about this one? It's still the row number, so it equals the axis equals 0 means that you are deleting the rows, and the 2, 3, that means that you are deleting the which rows? Yes, third and fourth. Yeah. It should also allow you to use that indexing we learned. For example, I have to delete multiple rows. I can use this one. That means the third row from number 2 to number 2, 3, 4, right? 3 rows. Do we want to do an experiment? We can try an experiment to see that. Okay. I'll just use the one we use here now. We are using. So for example, we have C, still have C. C is this one, okay? So we want to, we have to assign another one. Probably delete, and we give it to the array, member of the array, and we want to delete this this 3 columns, this one, and this one. So I would give it which number I will give it 2 to
5.
yeah 2 to 5, and then axis should be 1. Yeah. Let's rename it D and print D. Okay. I'm not sure if this code changes C or not. Actually, it may have changed C or it may not. So it tells me it's actually invalid syntax. I believe it should allow. So it worked. I'm surprised it doesn't allow me to do the multiple areas with this one. I feel it should allow multiple areas like this. Obviously, it doesn't allow me to do that. Or what you can do is give it a Numpy. If you really want to do like a lot of multiple areas, yeah, you probably have to do this. Then if you give it an, for example, if you give it this will give it multiple rows like this. Okay, so it didn't allow us to use that indexing 2 to 5. So I just generate a new list 2, 3, 2, 3, 5 with these 2, 3, 4 with these 3 numbers. But I'm very surprised it doesn't allow me to do that. I feel it should. Okay, so the next one tells us is that yeah. So for the if it's a 1D array, you can delete any of the elements. But for 2D array, usually you just delete the entire row or entire column. This one, it deleted the element at the position 1, 2, 3, at the index position 1, 2, 3. Okay, actually it's the second, third, fourth number. Okay. Another thing you may use it often is actually you delete the elements by the condition, by the value. And about I want to delete the members. The members that are all smaller, between 10 and 20. Okay, want to delete all the members between 10 and 20. So what I can do is to use this condition, array indexing, array, and then you give this condition and array smaller than. Right here, let's try it if it works for the C. Okay, C and C larger than 10 and C smaller than 20. Let's see if it works or not. Name it. Sorry. Okay, it did work. However, change the shape into 1D array, yes, or else it cannot align with each other because you are taking out the numbers from in the middle, it will not align. So is this correct? This is correct, right? C larger than 10 and C smaller than 20. So if you operate it on a 2D array, you take out these elements and the array is flattened, change it into a 1D array. Do you see that? It makes more sense if you take the elements out from a 1D array, okay, it's still a 1D array easily. But if you take out these elements from a 2D array, or take this part out, then it cannot align with each other anymore. So it has the function itself flattened it into a 1D array. So that's a function for deleting some elements. What you usually do is delete, maybe we often use it as a delete from a 1D array. Okay. And the next thing I want to talk about is sorting. So you can sort by descending order, or you can sort by ascending order. So this one. Let's try this. Let's do the integer, okay? It'll be easy to see. What else we need to tell it? If it's a random integer, we have to tell it the range and how many numbers we want, right? It should be the shape. So it's okay. Let's just try this. They give the I want here. Int object has no attribute to sort. So let's see what's the difference here. This only gives us one member. I believe we should okay. So now let's try sort. Let's just try a 1D array, okay? 1D array, then this should be, for example, 8. Okay, now I try to use sort. This sort function by default sorted into the ascending order. And another way, instead of using sort function, you can use the indexing to sort the arrays. For example, here. So let's try this one again, okay? Not sorted. This is the array, okay? With random number again. So if I do use the indexing to sort it, which means I have the start number and the end number, and then the last one is the step, right? So instead of going 1, 2, 3, that means going from going 1 means that goes by each number, and 2 means only takes out the every 2 numbers. And if you change this into -1, that means the step is going from backwards. So if you go this, no, I don't think it can sort. It's sorted. I don't think it is sorted. Actually, I think this code is wrong. So add this line again. Oh, okay, okay. This will be. This means so if you sorted it, it's in the after you sort it. After you sort it, this is in ascending order, and this -1, then it will change it into the descending order. So let's do this again, okay? And then you print this. As you see, this line is sorted it, but it's an ascending order. It goes from smallest to the largest. And I want to go from the largest to smallest. What you can do is just add a minus. So it will go from the last number to the first number. That's how we change it into a descending order. And the 2D array, so the 2D array, you can sort the array by the column or by the rows. Let's see, sort the rows by each. Yes. For example, let's try this. So here, this is a new array, 2D array. So if I sort by the rows, it should be what? It's actually sort by the columns. So if I sort by the columns, it will be 5, 21, 85, and then this row will be 8, 12, 25, because you're sorting by the columns. Now, column number 0, 1, 2, sorting by the columns. Okay? And this one is correct. So, and it will not change the number order. So this one, I will change it into 8, 12, 25. Let's see, you sort by column, and then now you print out the end. Yeah, you see, if you sort by the column, it will change the order in each row. And if you sort by the rows, then it will change in this direction. Okay, so 525 is correct, and this one it will be switched to 821, and this one you will be switched to 12 85. That is sorted by the rows. This is a little bit hard to understand. Sometimes I get confused also, because usually when we say sort by the rows, okay, we sort the first row and we sort the second row. But here the concept is a little bit different. You sort by the rows. You sort by rows means that hey, their row is axis row axis, right? Zero axis 0 is by the rows. So which means that you sort row 1, row 2, and here you sort row 1, row 2. Okay. So this doesn't change, and this will change to 8 and 21, 1 and 85. Okay, so it's a little bit harder to understand or to get correct. So make sure when you do the assignment, after you run the code, you need to verify the result. Okay. Yeah, every time you print out the result, and you need to verify, and maybe even have to write out with your pencil and to see if it's the same. Okay, next one we need to talk about is the Numpy operations. That's an advantage of a Numpy package. You can easily do the operations without writing the rules. For example, here I have an array M with 2 and 2 by 4 dimension, and an array 2 by 4 dimension. And if these two are listed, I probably have to write a loop to add each element together, m plus n. However, here you can just do m plus n to add each element together. Let's show you here. I do the int. Okay, here you see it's a 2 by 4 array and a 2 by 4 array, and this number it's from m plus n. Okay, and this number is also m plus n from. They match to each other, and you can do the sum directly. The same for the other operations. If n is a number, it's just like if n is a 2 by 1 array. Let's see what will happen. So you see n is a 2 by 1 array, so which means that it has 2 rows, 40 and 60, 67. What it does, it's added but to each column. This has 1 column only, right? 2 rows and but only 1 column. So this 40 is and the 60 is added to each column. And it's the same if n is only a number, 60. And then the 60 is added to each number. And this concept is called broadcasting. So Numpy knows by default you want to add this number to the whole array, or you want to add that column to the whole array by each column. So this is called broadcasting. Yeah, more operations. For example, I want to sum up all these numbers of the array, get the sum of all the elements from the array. Then you can just do a dot sum. Okay. Then it tells me the sum of all these numbers. And occasionally, you want to sum by the rows or by the columns. Then you can tell it the axis. For example, I want to sum by the rows. Sum by the rows, which means 89 add which numbers? Sum by the rows. So if I do axis equals 0, that means I'm sum up by the rows. Then what would be the result? M is this area, okay? What will be the result? Yeah. What did you say? 89. Yes, 89 will be added to 39. It will return an array 4 by 1 if you sum by the rows. See, 89 will be added to 39. And if you add by the column, then that means it will go to this direction. It will return an array that is 2 by 1. Yes, 2 by 1. Yeah, it's 1 by 2. Okay, 1 by 2. As 1D array. So this is the sum. Okay, the last one I want to mention here is the concept of element-wise multiplication and matrix multiplication. So if you like learn neural networks or some other, have to do some more complicated multiplications, you may need to use this concept. Element-wise multiplication is like what we did here. This is a matched. Did I erase that? Yeah. So for the element-wise multiplication, it's like the sum we just did. It goes A1 here, this one times it will be matched to this one to do the multiplication. Okay, element-wise, it matched each element. 6 times 0, 9 times 6, matched by the positions. We clear here? Yeah. But if we do the matrix multiplication, it's a different concept. This will not work actually. And I use another function. It's called a Numpy dot. If you use a Numpy dot multiply, it's the same as m times n, just the code we wrote. However, if you use a Numpy dot, that means it's doing the matrix multiplication. So here, if I do this one, I'll show you. I believe this is the right code. Yeah. Let's see if it will work. So actually, it tells me the position doesn't align with each other because it's not matching by each element now. What it does is see here. See this one, okay? What it does is this new number, it gives you a new matrix. So matrix also means a 2D array. We call all the 2D array matrix. What it does, this function it does is that the first element is from the first row and first column. And the second element here is from the first row and the second column. And here also the first row, the first row is the I didn't brought anything to draw. Okay, I can draw. Let's draw 4 numbers, okay? And this is the second matrix. So this new number, this number is from here to here together. That goes to this number. And this number is from this part and this part. That goes to this part. Okay. And the same with this number. This one is so this row number is from actually we can understand like the row number from this new matrix is from the first matrix. And then the column number of this number is from the second matrix. So this one, it's from this is second row. So this number is from the second row in the first matrix and the first column from the second matrix. A little bit harder to understand. You have to do numbers on your with your pencil to understand this concept. Okay, let's just do some math. For example, I have here. Okay. So, draw on your paper and tell me what will be the result if I do this numpy dot m time mn. You use your pencil to draw. let's just write this number, okay? We can just this a long matrix. So let's just write out these two numbers. Calculate these two numbers in the new matrix. As I said, this should be first row and the first column. So the numbers should be from the first row from the first matrix, and then the column number is from the second matrix. So this one should be first row and the first column. However, this one is let's use this one instead. Okay, this one it's the second row, so the row number it should use is from the second row, and then the column number is from the second matrix. So it should use the 1, 2, 3, the third column number to times this column number. Does that make sense? So this one should be like a M, okay? M, first row. Row 1 times N column. The second matrix provide its column number. So this one should be from times N, the first column from N. So this should be the column 1. And these both have 3 elements. So you see the first row has 3 elements and the first column has 3 elements, so they can multiply with each other. And this one tells me which row should we get from Emma. This is second row, right? Second row in the new matrix. So it should get the Emma. Which row? Second row. And the column, this is a plus actually. This is yes, times. So row 2, because this in the new matrix it's the second row, and this column, the column number should be from the second matrix. So this should be from N, third column here. This is third column. Where is the third column? What are the numbers from third column? 1, 4, 3. So this should be N. N column 3. Okay. Column 3. This will make it the new number here. So yeah, do this multiplication and tell me what are these two numbers. Just draw it on your paper. Yeah, you can form a group and do it together with your partner. This is the hardest part of today's lesson, okay? Mhm.
On the south shore or on the either severe kind of like just doing all of what's on the board.
Oh, I should have showed that later.